Okay, now we're going to look at the back of our notes page. And these are the problems where we are solving for y. We will be working a lot of these problems, and this is why we learn how to do our literal equations right now. It's because we are going to start solving for y, so that way we can end up having our y equals mx plus b form when we start graphing these. So our variable that we are solving for is the y, so I'm going to mark that. That's what I want to get rid of everything else over here. We're still going to use the exact same steps. We're still going to use whatever inverse operations we need to in order to get everything away from this y on the left-hand side of our equation. So the first thing I'm going to do is I'm going to subtract 5x, because that's a positive 5x. And this is the addition problem up here, so I'm going to subtract it to get rid of it, which means I have to subtract 5x from the other side of my equation. And when I do that, 5x minus 5x is 0. And 0 plus y leaves us with just y equal to, and now the 9 and the 5x, I cannot combine those. They are not like terms. This has an x on it. This is a constant. It does not have an x. So I cannot combine those. So I'm just going to write them both out. Minus 5x plus 9. Now, if you wrote 9 minus 5x, that's fine. That's the same thing. So long as you have that negative sign in front of the 5, it works either way. I went ahead and put it in this form because when you look at it, you'll see that this is now in our y equals mx plus b. So it's a lot easier to see it this way. But again, either way will work. So we're doing our same thing. We are using our inverse operations. So now take a moment and pause. Oh, nope, hang on. We're going to do example 5 first. Okay, so for example 5, same thing. We're solving for y. So I want to get the y all by itself. Now notice how we have that minus sign in front of the y. We don't see a coefficient there, but that doesn't mean we don't have one. And if you recall, going all the way back to when we did the distributing property, we have that invisible 1 in there. Write it in if you need to. Okay, that helps, especially on problems like this. So I'm going to write in that 1 in front of the y. And now I'm going to start by getting rid of my x. And just like the invisible 1, we can put the invisible plus sign in front of the x. So that means we're going to subtract x from both sides. So on the right side, or on the left side rather, we're left with negative 1 times y is equal to, on the right side, we have our 7 and minus x. Those are not like terms. We cannot combine them, so I'm just going to write them out. Negative x plus 7. Okay, now I still need to get rid of this negative that's in front of the y, because we don't want to know what y, or we don't want to know what negative y is equal to. We want to know what positive y is equal to. So in order to get rid of that negative 1, I'm going to divide by negative 1. And you have to divide the whole side by negative 1. So I'm going to divide everything on the right by negative 1. And so that leaves me with a positive y now on the left side, which is what I wanted. And then on the right side, when you divide by negative 1, all you do is change the sign of everything you're dividing by negative 1. So negative divided by negative is going to give us a positive x now. And then a positive 7 divided by negative 1 is going to change that to a negative 7. So this is what we get when we are solving for y on this problem. Y is equal to x minus 7. Now I want you to pause the video and go ahead and look at example 6. Go ahead and try that one on your own.